Alrighty. No, not a windowed preview. There we go. All right. So, good morning. This is April 7th. This is Algebra 2 CP A6. Today, what I'd like to do with you guys is I'd like to do a little review for you on applications of radical equations, as well as go back to just do a couple more solving equations problems. Never hurts to see a few more examples, so I figured that would be good to do with you today. Before we get started officially, I want to just give you a couple of reminders. First thing, as always, make sure that you check the daily attendance and make sure you fill out that Google form on Google Classroom. It's the same one we use every time, so just fill out that form. It takes a couple seconds to confirm that you are present for the day. Also, as advertised, after class today, we are going to have our progress assessment. It is going to be delivered to you via email after class today. It's actually scheduled to go out to you exactly at 11:10 a.m., which is right when our class ends. So what I'm asking is that you complete your work by the start of next class. That happens to be a long time for you. I'm trying to find my schedule right here. Our next class that we actually see each other is April 13th. I believe that's Monday. So that's plenty of time, I think, for you to get all of your progress assessment work done. All you have to do is just take a picture of it, send it to me via email, preferably by just replying to the same email thread so it stays all in one place. But just take a picture, attach your files, reply to the same email, and I'll get that graded and back to you as soon as possible. It's very important that you do get it done for that day so that I can grade it and provide you with feedback as fast as possible. Okay? If you're late on that, then it doesn't allow me to provide feedback prior to our summative assessment day. So I think that's more than reasonable. I think that's plenty of time before or for you to actually get that submitted to me. One thing that I want to remind you of as well is that on April 15th, we do have our summative assessment scheduled. I believe that's Wednesday. That's about a week from tomorrow. We do have our summative assessment scheduled that day. Essentially, what's going to happen is I'm going to post it in the morning. Either probably send it to you via email, just like I'm doing with the progress assessment, and say you have pretty much all day until about 6 o'clock p.m. to send it back to me. Same deal where you have to complete it, take a picture of it, send your work back to me, and I'll get that graded as soon as possible. All right. Again, that is going to be our day of the summative assessment. It's April 15th, so please make sure you complete it on that day. If there's any problems, please make sure to let me know ahead of time. Don't wait till that day and be like, oh, I can't make it because I had something to do. And it's like, well, tell me now so we can reschedule a proper day well in advance. But in any case, we'll cross that bridge when we get there, I guess. So today, like I said, I'd like to give you a little review on a couple applications, going over them from the homework, as well as just a few more solving equations examples. From the homework specifically, one of my students in one of my other classes, my A1, actually pointed out an error in the answer key on problem number 9. It was a very silly mistake too, like a foolish error. So I want to make sure I go over that one with you just to make sure there's no confusion on that. And I'll do problem number 10 as well because I think those are great. After I do 9 and 10, I'll ask if anybody else has any questions on any of the others, and if so, I'll be happy to do one of the other word problems as well. But other than that, I'd then like to transition to do just a couple examples of solving equations with you. So without any further ado, let's go ahead and jump in for number 9 on the homework. So number 9 on the solving equations homework looks like this. It says Heron's formula can be used to find the area of any triangle if you know the length of its sides. Heron's formula is defined as the area of the triangle is equal to the square root of s times s minus a times s minus b times s minus c, where s is equal to all of the sides added up and divided by 2. It's half of the perimeter, a plus b plus c divided by 2, and a, b, and c are the sides of the triangle. The actual geometry background is not necessarily the important part of this problem. The important part of this problem is, can you apply the algebra skills needed to actually solve it, right? So even though, yes, that's all well and good, it's good to know the actual geometric background, that's not really the crux of this problem. What the actual focus of this problem is whether or not you can use your algebra skills to give in some information, find some information that you don't know. So let's take a look here. I just want to make sure my camera focuses a little better. There we go. See that? The document camera. It's a little clearer now. So let's fill in what we know. Let's fill in what we know and solve for what we don't. It says that s is equal to 8 units. It says if s is equal to 8, the length of side A is equal to 7. The length of side B is equal to 4. and the area is 8 units. Can we now solve for side C? Well, certainly we can, because we have all the values for the other variables, so I'm just going to plug them in and solve for what I don't know. I have my area of 8 units is equal to the square root of S, which is equal to 8, times S minus A, that's 8 minus 7, times S minus B, that's 8 minus 4, times S minus C, that's 8 minus C, because I don't know what C actually is, but we're going to go ahead and solve for it. Okay? Working all of this out and simplifying the inside a little bit, I get that 8 is equal to 8 times 8 minus 7 is 1, times 8 minus 4 is 4, and that was actually the mistake on the answer key, was that I actually accidentally wrote, very silly mistake, please don't do this, I wrote that 8 minus 4 was equal to 3. It's a very silly thing to do, I know, I apologize, very embarrassing, but just make sure that you say 8 minus 4 is equal to 4, and you don't mess up those little subtraction steps. Sometimes when you're doing all these algebraic things and you're looking at the big picture, it can be easy to mess up those little tiny minute details. Now we can go ahead and multiply all this together on the inside. I get 8 is equal to the square root of 32 times 8 minus C. Now you may recognize that there's really not much more simplification to do on the inside. Let's get rid of that big old radical on the outside of everything by squaring both sides. I have 8 squared, which is 64, is equal to the square root and square cancel out on the right. That's 32 times 8 minus C. And now we could go ahead and solve. This is just back to like Algebra 1 land. We can divide both sides by 32. Luckily enough, that goes in nice and evenly with the 64. 2 is equal to 8 minus C. Certainly you could have distributed the 32 and then solved like an Algebra 1 equation, but that saves you a lot of work to do that. Subtract 8 from both sides. You get negative 6 is equal to the opposite of C. And if negative 6 is equal to the opposite of C, then it makes a lot of sense that C would equal positive 6. Okay? So that means any triangle like this that would have one side length of 7, one side length of 4, and an area of 8, the other side length would have to be 6. Any questions, comments, concerns about that? Hopefully that makes sense, yes? And again, I want to emphasize that the geometric background is not necessarily the really important part of this. It's interesting, and you should definitely, process that and understand the context of the problem. But the real thing that this is testing, so to speak, is your algebra skills. Speaking of which, let's take a look at problem number 10, which is another great problem from geometry, but again, it's really focused on your algebra skills. It says the area of a triangle is 36 square feet. If the base of the triangle is 8 feet and the height is the square root of x minus 1 feet, what is the value of x, and then what, therefore, is the height of the triangle? So it doesn't actually give you a specific formula, but hopefully you remembered from geometry that if you have any old triangle, just like this, and you create this altitude representing the height, and this is your base, you would be able to find the area of the triangle by doing 1/2 base times height, right? That comes straight from geometry. Hopefully you're able to remember that and recall that formula for this, where you're like, ooh, area of a triangle, I know how to do that. Let's go ahead and plug in what we know and solve for what we don't. It says the area is 36 square feet, and that's equal to, let's see, the base of the triangle is 8, so 1/2 base of 8 times the height of the square root of x minus 1. And that should be exactly how we set up our equation. So now we can take an equation like that and solve for x no problem, right? I got 36 is equal to 1/2 of 8 is 4 times the square root of x minus 1. We can divide both sides by 4. You would get that 9 is equal to the square root of x minus 1. Now, this is like one of the solving radical problems that we actually started with, one of the most basic ones. We just square both sides. The square root and square on the right side cancel out. Here I get 9 squared is 81 is equal to x minus 1. And then just add 1 to both sides. You get that x is equal to 82. Okay? So that's the first part of the problem. It says what is the value of x? And then the second part of the problem says what therefore is the height of the triangle. Very important to note, the height is not 82 feet. That would be a very, very skinny triangle if the base is only 8 feet and has a height of 82 feet. It would go way, way up. It means that x is equal to 82, so we can use this value for x to plug it into the height, which was the square root of x minus 1, and actually get that the height was the square root of 82 minus 1, or the square root of 81, which is 9 units. Okay. Any questions, comments, concerns about problems 9 or 10 that we just talked about? And any questions, comments, concerns about the other word problems? There were 6, 7, and 8 as well. Do you want to see any of those, or are we happy with those? Thinking about it, processing perhaps, absorbing all the information. We're good to go. Okay, I take your silence as yes, we're good to go. Oh, Sean chiming in. Can you go over number 7? Oh yeah, sure. Why not? Absolutely. Absolutely. Let's do it. Okay. It's just about, Sean, you caught me just in the nick of time. That was great. That was clutch. Okay, here we go. Number 7, sure. Number 7 says, this is just a random formula. It says a survey shows that the supply of computers, which is increasing in recent years, for sure, can be calculated by the function. We have the supply over time, S of t, is equal to 33.2 times the square root of 2 plus 2.9t. Okay? Where S represents the supply in millions of computers and t represents the time in years. How many years will it take for the supply of computers to reach 132.2 million, and then round your answer to the nearest tenth? So all this is asking is it's saying here's a formula. When will this formula output an answer of 132.2? So we're just trying to find what value for t makes that possible. Now, definitely we're going to have to use a calculator in this particular instance. Let's see if we can simplify this a little bit first by dividing out that coefficient of the radical on the right side. I'm going to divide both sides by 33.2, meaning I'm going to do 132.2 divided by 33.2. We get about 3.98, we'll call it. And we'll say that that's equal to the square root of 2 plus 2.9t. We can now go ahead and square both sides of that to get rid of that big square root. Square both sides. I get on the left 3.98 squared is going to give me 15.84. I'll round that to 2 decimal places. And we'll say that that's equal to the square root and square go away. We got 2 plus 2.9t. And now, even though there's decimals, which may be somewhat uncomfortable for some people, it's still just the processes of Algebra 1, where I would isolate my variables. So I'm going to subtract 2 from both sides. That gives me 13.84 is equal to 2.9t. And now I'll just divide by 2.9. So we got 13.84 divided by 2.9. And I get an answer of about 4.77 years. So t would be about 4.77 years. Okay? So about almost 4 3/4 years, a little more than 4 3/4 years. So what's that, like 4 years and 9 months, right? Yeah, I think I can do that in my head. All right, we're good. Does that make sense to everybody, how that's done? So again, that's just a case of using a formula that's provided to you to solve for what you don't know. All right, let's take a look at just a couple more equations. I think it's beneficial to go back to take a look at just a couple of those. I'd actually be remiss if I did not show you an equation like the one I'm about to. So going back from our word problems now, let's see if we can jump back into solving equations, and remember checking for extraneous solutions and all that good stuff. So let's get started with a problem like this. Where did my problem go? I just want to make sure I copy it down correctly. Here we go. Nice solving equation example. If I told you that the square root of 22 minus 6x is equal to, oh sorry, not equal to, rats, new sheet, rats. All right, let's try it again. The square root of 22 minus 6x and then minus an additional x is equal to -5. That's more like it. Okay? How about a problem like that? We want to go ahead and solve that equation. Well, what I would want to do first is I'd want to isolate the radical, get it by itself. Right now there's this minus x stuck onto the end of it. So I'm going to go ahead and move that to the other side by adding x to both sides. That gives us the square root of 22 minus 6x is equal to, I can write this as x minus 5. You can certainly write it as -5 plus x if you so desire, whatever works for you. Okay? Now I can go ahead and get rid of this radical, which you should recognize is what we need to do. We've seen a lot of problems like this now. Get rid of the radical by squaring both sides. On the left, the square root and square cancel out. That's why we're squaring, to cancel out that square root. That gives me 22 minus 6x on that left side. On the right side, though, we have to do a little bit of distribution. I need to do a little first, outer, inner, last, which we, of course, all know is the distributive property. So that's x minus 5 multiplied by itself. We now are going to do exactly that. I got 22 minus 6x is equal to x squared. That's a first. Outer and inner combines to minus 10x, and the outer multiplication is plus 25. As soon as you see that value of x squared show up, that should be an immediate indication that we have to absolutely factor. But before we factor, we of course have to set equal to 0. So I'm going to do that by adding 6x to both sides. Like that. I'm going to subtract 22 from both sides. That gives me that 0 is equal to x squared. Here I have negative 10x plus 6x, so minus 4x. And 25 minus 22, so plus 3. We can now go ahead and factor that into two binomials. I need x and x to multiply to x squared. Since we're multiplying to a positive, but we're adding to a negative, we know both the signs have to be the same. It makes sense that they should both be negative. And now we're looking for factors of 3 that will combine with my distribution to get negative 4. That's going to be 3 and 1. Okay, so that gives me two potential solutions of x equals 3, because 3 minus 3 would make 0, and x equals 1, because 1 minus 1 would make 0. Of course, remember that I said these are two potential solutions because we, of course, have to check for extraneous solutions. So let's check. When x is equal to 3, is it true, just taking this 3, plugging way back up here, is it true that the square root of 22 minus 6 times 3 minus an additional 3 is equal to negative 5? Is that true? Let's see, we get 22 minus 18, so that's the square root of 4, minus 3 is equal to negative 5? I don't like it. I don't like it. The square root of 4 is 2, so 2 minus 3 is negative 5? No thanks. No thanks. But we've seen this happen before. That means that this guy is extraneous. No reason to panic, right? Means that we just have one extraneous solution. So let's go ahead and just test that other one. Let's check. When x is equal to 1, is it true that the square root, going way back up to the top again to plug in, the square root of 22 minus 6 times 1, and then minus an additional 1, is that equal to negative 5? Is that equal to negative 5? Well, let's find out. Here we get the square root of 22 minus 6. That's the square root of 16. Minus 1 is equal to negative 5. Oh, I like this one even less. This is even further away. This is now 4 minus 1 is equal to negative 5. No way. So, yikes. 1 is also extraneous. Which means that despite our best efforts to find solutions here, we found that both potential solutions are extraneous, which means that this problem actually has no solution. Okay? It has two extraneous solutions of x equals 3 and x equals 1, but it has no solution. That's why I said I'd be remiss if I didn't show you a problem like that, because we have yet to see an example that works out to no solution, but it is certainly possible that you could work out through perfectly legitimate algebra. We get our two answers, but when we go back to plug them in, it doesn't work. Doesn't work. But that's okay. No solution is still an answer. Don't be discouraged. Don't be discouraged. Does anyone have a question about that problem? Okay, one more. We got about 10 minutes to go. I want to show you that double distribution problem. You know I love those. Because they really go over all of the algebra skills that you should be expected to do at this point. Distribution with radicals, combining like terms, isolating variables. It's kind of all thrown into one problem. So let's take a look at something like this. Ready? We got another example. How about the square root? Plus, I think it never hurts to see more of these. Negative 2 minus 2n is equal to negative 3 plus the square root of 1 minus 8n. Okay, just because it's n and not x doesn't mean that everything is, the universe is exploding. So I now have this problem. Notice that this is one of our double distribution problems because it's impossible to isolate both radicals simultaneously. This negative 3 is currently stuck to this square root, and you might be like, well, that's a bummer. Let's get it out of there. But if we just added 3 over to this side, now it's going to be stuck to this one. So either way, you're going to be left with one radical that you can't isolate right away. So we just have to deal with it by squaring both sides and doing some distribution with that radical. Okay. On the left, it's nice and easy. The square root and square cancel out. I get negative 2 minus 2n is equal to, I'm going to square this side, which means multiply it by itself. Negative 3 plus the square root of 1 minus 8n times itself. Just like that, yes? I can now do a little first, outer, inner, last on that right side. Left side staying negative 2 minus 2n is equal to negative 3 times negative 3 is positive 9. Negative 3 times the square root of 1 minus 8n is exactly that, minus 3 square root of 1 minus 8n. Same thing on the middle, right? We got square root of 1 minus 8n times negative 3 is exactly that, negative 3 square roots of 1 minus 8n. Again, it's just like if you were doing negative 3 times x, you would write negative 3x, or n in this case. Negative 3 times n, you'd write negative 3n. It's the same deal. I'm doing negative 3 times this square root is exactly that. You now have negative 3 square roots of 1 minus 8n. And then lastly, the square root of 1 minus 8n times the square root of 1 minus 8n is just 1 minus 8n. Just like how saying the square root of 5 times the square root of 5 is the square root of 25, which is 5. The square root of 7 times the square root of 7 is the square root of 49, which is 7. The square root of any number times itself is equal to just what's under the radical. All right, in any case, going forward from here, let's clean up that right side by saying we now have negative 2 minus 2n on the left. I have this constant of 9 and this constant of 1, so altogether that makes 10. I have a minus 8n, which is not combined with anything. And now I have negative 3 of these radicals and another negative 3 of these radicals. So altogether I have negative 6 of these radicals. Okay? Very common mistake a lot of students do is they like to try to do this, combine 9 minus 3 and make 6 square root of this. Please, please, please do not do that. It would just be like if you had 9 minus 3x, you wouldn't make that some hybrid term, so don't go there. All right. Now I have one radical, so I want to isolate that radical by moving everything else over to this side. Let's subtract 10. Let's add 8n just to get that radical by itself again. I get negative 12. Here we get plus 6n is equal to negative 6 times the square root of 1 minus 8n. Once again, remember that I told you at this particular step, it's important to check for, can I divide everything by this coefficient evenly? Because if so, that allows me to just simplify the numbers I'm working with and reduce down. If I can't, then maybe I can divide by like a common factor. For example, if this were a 10 and this were an 8, yes, we could not divide by 6, but I would be able to divide everything by 2, which would help simplify everything down, so I'm working with smaller numbers. Here, it's actually the best case scenario where I can go ahead and divide everything by negative 6. Just like that. Okay? And by the way, if you can't do that, then you just got to deal with it. You're just going to have to square both sides and distribute. It's not the end of the world. It's a little more annoying because the numbers will get a little larger, but it's certainly not impossible. We've seen problems where we can't divide and you just got to roll with it. So here I get negative 12 divided by negative 6 is 2. Negative 6 divided by negative 6 is minus 1. And that's equal to, these go away, I got the square root of 1 minus 8n. And now this is a problem just like this, right? Is it not pretty much just like the starting point of my previous problem where it's just the square root is equal to a binomial? So we're just going to solve it the exact same way. It's like all that work was really required to reduce my difficult problem down to one that's certainly more manageable. I can square both sides to get rid of the radical. Square root and square cancel out. On the left, we need to do 2 minus n times itself. On the right, we just get 1 minus 8n. Little first, outer, inner, last gives us 2 times 2 is 4. Minus 2n is minus 4n. And then negative n times negative n plus n squared is equal to 1 minus 8n. Again, you see that value of n squared in this case, normally x squared, but n squared in this case, immediate indication that we need to factor. So we got to set equal to 0 first, subtract 1 from both sides, add 8n to both sides. You get, just to write it in a familiar order, n squared plus 4n plus 3 is equal to 0. Coincidentally, kind of a similar quadratic expression to what we had in the last problem. I'm going to factor down to two binomials. We get n plus 3 and n plus 1, because that's what we need to factor to this, right? We need n and n to make n squared. Everything's positive, so why introduce any negatives? And then I'm looking for factors of 3 that combine to give me my 4. This gives me two potential solutions, one of n equals negative 3 and one of n equals negative 1. Okay? Hopefully no question as to how I got those solutions. If you have a question, please feel free to interrupt. But we're not quite done yet. We do still have to check for extraneous solutions. So let's do that now. Let's check when n is equal to negative 3, going way back up to the top here. Is it true that negative 2, the square root of negative 2 minus 2 times negative 3 is equal to negative 3 plus the square root of 1 minus 8 times negative 3. Does this work? Again, all I did is I went right back up to the top. I plugged in negative 3 for all of my n's. Let's see. Negative 2 plus 6, that's the square root of 4. Is that equal to negative 3 plus, this looks like the square root of 5. Oh, sorry, the square root of 25, right? Because 1 plus 24. I think this works out, right? Is 2 equal to negative 3 plus 5? It certainly is, so I'm happy with that. And now let's just check the last one. I'll do it right over here. When n is equal to negative 1, is it true that, going again way back up to the top to plug in, the square root of negative 2 minus 2 times negative 1, I made that square root way too long, is equal to negative 3 plus the square root of 1 minus 8 times negative 1. Is that true? Let's see. We got negative 2 plus 2, so it looks like the square root of 0, is equal to negative 3 plus the square root of 9. Negative 3 plus the square root of 9. Is that true? I think it certainly is, right? Because 0 is certainly equal to negative 3 plus 3, so I'm happy with that. And so this problem, unlike the last one, which had no solution, this problem has two solutions. They both check out. Those two solutions are n equals negative 3 and n equals negative 1. Alrighty. So we managed to go over 3 word problems and 2 equations today. Does anybody have any questions or concerns at all, in the slightest, as to how any of those problems were done? Going once. Questions, comments, concerns. Going twice. Questions, comments, concerns. All right, gone 3 times. Just another reminder is that your progress assessment should be arriving in your inbox within the next minute. Please make sure you complete it by taking a picture of your work and emailing it back to me by the start of our next class period together. Our next class period together is Monday, April 13th, so please make sure you get it back to me. The sooner you get it back to me, the sooner I can grade it and provide you feedback. So if you want to do it early, you're more than welcome to do it early, but it should be arriving in your inbox very shortly. Again, just another reminder that our summative assessment is April 15th, so please make sure you get that done. Other than that, that's all I got for you guys today. I hope you have a fantastic rest of your day. I won't actually see you before our long weekend, so I hope you enjoy our long weekend. Remember, there's no school Thursday, no school Friday, and we got, of course, Saturday, Sunday off. So the next time I will see you guys is on Monday. Enjoy. Have a great day. Remember to sign in for attendance, and thank you so much for your attention today. Later.